Hello, this is Brian Mullen, and this video is going to be covering my cloud-in-a-box CIAB Mesh VPN Internetworking Overlay Architecture installation in a step-by-step fashion. I have two cloud servers, one on DigitalOcean, that's the DO-server, one on Hetzner's cloud in Germany, that's the Hetzner-server, and one is a local LXD VM, not container, but a VM on my local machine. We're going to begin by covering the introduction of my installation guide, and hopefully I worked out most of the mistakes on this. Anybody that's written user guides knows how difficult it is to write up an extensive user guide for a complex subject when you tend to gloss over some things because you've done it so many times, it's just familiar to you, and you don't give a proper explanation of each step. I've tried to go through this document several times now. I'd actually sent it out to several friends with a rather embarrassing mistake in step number 7, but we'll cover that in a little bit. I've since corrected that step and added some additional installation steps that I should have had the first time to make things clearer about what you're doing. Anyway, you could pick any one of these machines, these servers, to do the general installation steps, which we'll cover in a bit. So any one of them, I'm going to use my VM1, which is a LXD VM on my home machine. But first, I'd like to go over a little bit of the introduction to this guide. I've implemented this Mesh VPN Internet Networking Overlay using BGP, VXLAN, BGP VRFs, and LXD. The end results is a multi-node, node being the server, VM, anything that's the equivalent of a server, Linux server, multi-cloud or hybrid being an architecture that is part local to your data center and part in the cloud, or everything could be in one cloud or many clouds. But this architecture will allow the interconnection of the private 10.x LXD container networks across all connected Mesh VPN nodes. This CIAB architecture utilizes all open source technology, including free range routing, FRR. The FRR is a routing protocol suite for Linux, which includes protocol daemons for BGP, OSPF, RIP, many other protocols. It also includes use of virtual extensible LAN, VXLAN. And there's a picture here of a VXLAN network model. This is a generic picture, not necessarily what we're building, but this is more or less the same overall look. The architecture also uses BGP and BGP route reflectors. The first picture is a full mesh BGP network not using route reflectors. In that environment, in that type of configuration, every BGP node has to peer to every other BGP node. This creates an excess of traffic. It's harder to manage, harder to configure, or more extensive configuration. But there is a resolution to simplify that using what's called BGP route reflectors. The BGP route reflectors is just one method to get rid of the full mesh of IBGP peers in the network, but it still allows all routing information between, to and from all nodes that are connected in the network. A full BGP network when using route reflectors, as you can see, is much simplified. Every node is connected to every other node with routing information that allows that any node to directly connect to one of the peers without necessarily having to exchange routing information directly with that peer. The architecture also uses at its core the Wireguard VPN. Wireguard is now built in to the Linux kernel. So if you're using current/modern Linux, you will probably already have Wireguard installed as part of the Linux kernel. Because of this, there's no user space back and forth between the kernel and user space, which would slow down the VPN. And Wireguard is considered a state-of-the-art VPN, in particular in regards to performance and its cryptography capabilities. The architecture also uses LXD. LXD is technology that provides system containers, which means that a container that runs a full Linux distro. LXD does support creation and use of containers that are running Debian, Ubuntu, Fedora, CentOS, Alpine Linux, Oracle Linux, OpenSUSE, and others. I'm also utilizing a tool that you can find on GitHub. There's a link here for that too, called Wireguard Generator. That's a great tool that, in my mind, that's provided a lot of ease and capability to the creation of this overall architecture. The Wireguard background is that it creates or utilizes 3 different layers of IP addresses. And there's the public IP address of each node or server, which is that node or server's real public IP address, public-facing IP address. The VXLAN virtual tunnel endpoint address, or VTEP. You'll hear the term VTEP throughout this guide and the installation. VTEP is the term used to identify the terminating endpoint of a VXLAN tunnel on each node. So each node would have, in this architecture, one VTEP interface created and with an IP address by the time we're done. Then there's also the IP addresses that Wireguard uses itself for its VPN. Those are allocated by a pool of IPv4 and IPv6 addresses that in the later steps we'll specify during the creation of what's called the master Wireguard configuration file. Since all nodes are connected to a virtual LAN, you may want to, and usually you would, have all these prefer all the addresses to reside in single subnets. If you're not satisfied with the automatic allocation for IPv4 or IPv6, you can add more than one address and set one of them as a primary. Important to the goals of the CIAB Mesh VPN Internetworking Overlay Project are 6 key performance indicators, KPIs. Number one is security and secure communications. In today's world, when you're building a network, a corporate network, or a educational network, um, there is no end to threats from hackers, either snooping on your traffic, trying to intrude into what you're doing, disrupting your business or your constituents' activities. Everything is open source in this architecture. And number three, the architecture supports use of LXD containers and LXD VMs. Number four is it needs to be simple and easy installation, configuration, and expansion. Multi-node, number five, is that it should be capable of interconnecting multiple hosts on multiple clouds, multiple data centers, as if they were on the same LAN. So an LXD container or a VM on any one node can directly talk to and interact with an LXD container or VM on any other node. So you could have web servers on one node with a database on a completely different node in the cloud, etc. But they have transparent access to each other, but not from someone outside of the Mesh VPN. It also needs to be multi-cloud and support hybrid cloud architectures. Multi-cloud being what we'll see here, where I'm using DigitalOcean and Hetzner clouds. DigitalOcean's server is here in the United States on the East Coast. Hetzner's cloud is in Germany, and that's where that server, Hetzner server, is. And VM1 is on a local machine here with me. But the fact that I'll be able to interconnect all of those fairly transparently is another KPI for this architecture. There are some assumptions in the installation guide. One is that you'd be utilizing either an Ubuntu 18.04 or Ubuntu 20.04 desktop or server system. I've used both 18.04 and 20.04. All of these servers that you'll see today are Ubuntu 20.04 long-term support server version of Ubuntu, not the desktop version. But you could use the desktop version. You should make sure that LXD is already installed and an LXD init has been done on each node. Just accept the default prompts on when you do the LXD init. I would recommend using the snap version of LXD. That's what I'm using here. There is a total of 15 steps that I've documented. Most of them are very quick. Some are just one-liners. But in item C, you'll see that steps 5 through 11 only need to be done on one node. So you pick any one of these servers. I'll use my VM1 server for those steps. Then steps 1, 2, 3, 4, and 12 through 15 would need to be performed on all nodes and servers in the mesh that you're trying to create. That's going to include configuration files for FRRs, free range routings, BGP, and Wireguard, and VXLAN. The installation guide does not cover multi-tenant configuration, although this can be done. It's not overly complex. I've a separate document that covers the steps required for that. But in general, that requires utilization of what's termed multi-AS, multi-autonomous systems configuration within FRR. But I will not be going through that in this guide. So let's begin. Step one, I've already accomplished. I've created the servers on Hetzner's cloud, DigitalOcean cloud, and my local VM. They're all Ubuntu 2004. So we'll skip to step two. And on step two, we're going to install FRR on each node. So we'll begin by doing that. Actually, I'm going to do this a simpler way, since some of these steps. I'm using the Terminator terminal program, and that does allow you to issue commands in one terminal that are replicated in every other terminal. So we're going to use that to save us some typing. So as you see, as I enter sudo apt install FRR, it appears in all the other servers. So I'm going to enter my password, and FRR will be installed. Some a little faster than others. Okay, it's done on all three nodes. Now we're going to install WireGuard and WireGuard tools on each node. And as you can see, it's done on each node. The next we're going to do is when FRR was installed, it created a directory, a configuration directory in /etc/FRR, and in that is a file named daemons. That, if you read up on FRR, you'll find out that it supports a lot of different protocol daemons, and you can enable or disable any of those. We're going to use our capability to execute a command on all of these at the same time, and I'm just going to edit it. All we need to activate for FRR is BGP. So we're going to type yes here, and as you see in each one of these configuration files, BGP daemon is set to yes. We're going to save that, exit. Now, I have a set of scripts that I've built to make things simpler for me, mainly because I'm old. I forget command syntaxes and constantly have to look them up. It was easier just to build these scripts. As part of obtaining the guide, my guide here, you'll get a zip file that contains these scripts. I put an explanation of what each script does. WireGuard-meshup.sh starts WireGuard on a node, mesh down, shuts down WireGuard on a node. Here are the commands to start, restart, get status, and stop FRR. Note that you have to have WireGuard up and running before you utilize FRR or start FRR or restart it. By the way, the restart command here for FRR and restart command for BGP, the basic functionality is basically in the script it stops FRR or BGP, then it just starts it again. This just saves you from having to execute two commands. But in FRR, you start free range routing, you restart it, you can get status, and you can stop it. BGP has the same has a prereq as well. In order to start, restart, or stop BGP, FRR needs to be running, and FRR can only be running if you already have WireGuard running. There is one further. It's not really a script, but I've included it as a binary program. The source code can be found here, and its purpose is fairly explanatory. This application, generate-IPv6, is only called from the mesh up, WireGuard mesh up SH. And its purpose is to create a guaranteed, or should be guaranteed unique IPv6 address to be assigned in the configurations. This would prevent any possibility of having a link local IPv6 address duplicated across a large VPN. So anyway, I wanted to explain, if you don't want to use the binary I've included, you can go to this website, download the code, compile it yourself, and you'll get the same results. When you unzip or untar all of these scripts in this binary, you should place them in someplace on each system. These will all go on each server, each node in your Mesh VPN. You should put them in a directory that is either always accessible to you, like /user/bin, or if you have, like myself, I've created a non-root user on each server, bmullen, and I've just put these scripts in the bmullen home directory. So if you look, you'll see that all of these have the same scripts. And if you look at any scripts, they're all fairly simple. If we looked at wg-mesh up.sh, all this does is use the WireGuard wg quick command to bring up the CIAB Mesh VPN network and assign the IPv6 address to the interface that will be named CIAB Mesh once the VPN is active, is started. So step 5 is we're going to install and configure WireGuard, VX WireGuard generator. For that, I'm going to turn off this broadcast capability. I don't want this executed. You only need to, again, go back to the beginning. Step 5 only needs to be executed on one of the nodes. I'm going to use my local VM. So first things first, and some of these may throw an error when I execute it, but that's simply because I'd already done it on the servers, and it probably already exists. But as for here, unzip's already on this server. Next thing, we want to use wget to get VX WireGuard generator code off of GitHub. And since I'd already had that down here, now you see there's 2 of them, but I'm just going to delete that second one, which is rename RM, because I don't need it twice. And then you would unzip master.zip, and that would create another directory for you. I just the directory it creates when you unzip the one you download has a longer name to it, so I just renamed that directory master. So we'll cd to master. It normally would call that directory VX WireGuard-generator-master, and I didn't want to have to type all that. These next steps, the prereqs for utilizing VX WireGuard generator, are to install Python 3 pip, then install using pip 3 to install all the requirements specified in the requirements.txt file, and that's this file. Then building the setup.py, which is this. I've already done all these, so I'll execute the commands, but they're just they're just going to speed back that it's already exists. And I'll just show you what's in that requirements file. So the requirements.txt files, you can use pip3 to install TOML and PY-NACL. But those have already been installed here. We'll go to step 6. Create a master config file for our CIAB Mesh VPN using this. First thing we're going to create is a directory to work in. So I recommend, in the guide, I say create CIAB VPN. I've already got that. And in that, we'll remove all these config files that I've already done. We'll just start over fresh. So, Wireguard has a central tool, CLI tool called VWGen. If you want to see everything that VWGen can do, all the subcommands that it supports, you can execute VWGen --help. And as you see here, same information is here. Just wanted to show you that command. It does more than one thing. So the next step here is going to be creating, whether it's a politically correct term anymore or not, the master configuration file for Wireguard. I call it a master configuration file because this configuration file will end up having all of the nodes in your VPN, Mesh VPN configurations inside of the one file. Later, you will use VWGen to extract each individual node's individual WireGuard configuration. And so we'll go through and show you this part step by step so you understand what it's doing. So we're going to go VWGen add CIAB Mesh. Now, I'm calling it CIAB Mesh. You can call it whatever you want. But if you do, make sure you change and recognize that the name you give this is going to be utilized in other places in this config guide, as well as one of the interface names will take on this name as well. But because we're configuring the CIAB VPN mesh architecture, we're going to stay with this. So now, as you see, it's created a CIABmesh.conf file. If we were to look at that right now, it's fairly vanilla. There's not much in there, and there's no node definitions yet. Now, Wireguard, as I mentioned, was a great tool because it does a lot. It does the WireGuard configuration and the VXLAN configuration work for you. But first thing you do, and it's explained here, is you're going to create a pool of non-routable IP addresses. And you can just use these two pools. There's the IPv4 pool and there's the IPv6 pool. So we created that pool. Now we're going to decide how many nodes. We're going to create a number of configuration files inside of CIABmesh.conf. One configuration section for each node that we want to create in our network, in the overlay network. You could have 3 nodes, you could have hundreds of nodes. This tool, again, does the work, most of the work for you. If you had hundreds of nodes, there is more work involved, obviously, just like with any tool, but you could create scripts to parse the master file for you and extract all those nodes, just as we're going to do here. So now we're going to use VWGen. Again, that's the main CLI tool for VX WireGuard. And we're going to create 3 nodes. Node 1, Node 2, Node 3. So now if we look at the master, first of all, we still only have the master configuration file, but if we were to look at that now, you'll see that we have a Node 1, we have a Node 2, and we have a Node 3. So we're going to keep going here. I also described how if you want to create like 50 nodes, there's a little, you can use the VWGen add command and a bit of bash type scripting to create 50 nodes and call all of the nodes myCN some number. And it would just name them myCN 01 through myCN 50. That was just a tip to save you some time. This is some background information about ports. IANA is the Internet Assigned Numbers Authority. They regulate the entire Internet in regards to port numbers. Well, IP, a lot more than port numbers, but the port numbers and well-known ports, they're defined as, well, I listed definitions here. I'm not going to read things here and insult your intelligence, but there's 3 different types of ports that IANA specifies. Port number ranges, well-known ports. Port numbers 0 to 1023 are well-known port. Port 1024 to 49,151 are registered ports. That's if you're an entity and you want to register a port to be dedicated only to your use. You can register a port number with IANA. And then these port numbers are free to use by anyone for any purpose you want to use them for. In this guide and in these examples, I'm going to pick port 50,000 because that falls in this range. And it's an easy number, again, because my memory, it's an easy number for me to remember. So we want to set the public IP address on each of our nodes configuration configuration section that's internal to the CIAB Mesh master config file. And the command to do that is VWGen set CIAB Mesh node, the node name that you're setting here, and the endpoint. This is the WireGuard endpoint. The public IP address of that node, and this could be IPv4 or IPv6, the port number, and then the listen port number. That's just an example. But we're going to, for our 3 nodes, we have to know the IP address of each one. So for this first one, my VM, we'll make that my node 1. We'll say IP address. And my public IP address is this, right here. So we're going to take this command and we're going to come back, and for the public IP address for node 1, make sure you don't delete these single quotes. We're going to put in 10. We're going to put in this IP address. Again, this is LXD, an LXD VM, and it's been assigned this 10 dot network by LXD when the VM was created. So now VWGen sets in the CIAB Mesh configuration, master configuration file, the node named node 1, its endpoint, public IP, WireGuard IP network, or IP address is going to be that, the 107.254.163, and port 50,000. Now we're going to do the same for these. This will be my node 2. And we'll cut and paste from here, from the guide. And for node 2, our public IP address is this. That's the IP address of the DigitalOcean server. Oops. Oh, I'm sorry. Again, these commands all have to be executed on the server I'm doing the master configuration for. Sorry, I'm losing my mind here. Oops. So we'll go back and copy this again. My mistake. Been a long night. And we're going to copy the public IP of node 2, which is this IP address. And paste it into the command. And for node 3, IP address, we're going to use the Ethernet 0 IP address. This is the public IP address of the Hetzner cloud server I've got. And now VWGen set in the CIAB Mesh master config file, the node 3, set its WireGuard endpoint to be 95.217.13.207, port 50,000, with a listen on port 50,000. So we've done that for all 3 servers. Now, this is a great command just to see what your master config file looks like. It also will show you a piece of information that you're going to want to either copy down, or you'll just execute this command again later, or use a grep and look for any single node if you need it. But this will also show you the VTEP address for each node. So now if you look, the CIAB Mesh master config file now contains a lot more information in each node, for each node. There's the public crypto key, a private crypto key, the public IP address for node 1, the port number for node 1, the VTEP, this is the VXLAN tunnel endpoint address for the VXLAN tunnel on node 1. So what later we'll see that's 172.20.10.108. And got its link layer IP address is this. That is for VXLAN as well. I won't go through the blacklist or the whitelist, but I think most of you are probably familiar with what those mean. Node 2 got a public IP of this, a VTEP of this IP address, 172.20. If you note, these are all on the same subnet. And node 3, same thing. It's got a public IP address, which is the server on Hetzner's Cloud's IP address. It's listing on port 50,000, and its VTEP address is again on 172.20.10 subnet, and its link layer IP address is 169.254.13.120. So now that we've gotten that far, these VTEP numbers are ones that, again, you'll probably want to remember. We'll come back to this later and get those as we need them in the rest of the configuration. Step 10, again, this is still only executed on the node you're doing the master configuration on. Oops. But now we're going to use the VWGen command, VWGen showconf, to split out each individual node's configuration file. So the first one will create node1.conf. This, instead of being the master file that contains all of the node's configurations, this will create an individual node configuration. And again, you could script all this up in a bash script or PHP or something if you didn't want to execute these one by one. So now I've got, oops, it would help if I get all the letters. Now if I do an ls, you'll see that I've got the master configuration file here. Now I've got individual configuration files, one for each server. Node 1 being this local LXD VM. Node 2 being the DigitalOcean cloud. Again, I'm just picking which one I call Node 1, Node 2, Node 3, Node 4. And when you do this, you could name these instead of Node 1, Node 2, Node 3, etc. right here for the config file. I could have changed this to be this command redirected to vm1.conf, this command redirected to do-server.conf, this one redirected to hetzner-server.conf, just to make them clearer, but since this is a small network, it's not hard to remember. But now if I were to look at node1.conf, this is just configuration information required for VM1's WireGuard to come up and connect with node 2 and node 3. If I were to look at node2.conf, this would be the configuration required for node 2, which would be my DigitalOcean server in my use, to connect to VM1 and to connect to the Hetzner server. And obviously, the node3.conf would be for the Hetzner server to connect to DigitalOcean and to connect to my VM. So let's see, step 11, let's bring this up a little bit. Oops. Step 11. Now, this part assumes you know how to copy files from one Linux server to another using SCP or FTP or whatever you use. So I will not go through that. I use SCP, but in this case, I haven't done that on this yet. So let's copy one of these. We'll say, well, first of all, on the VM1, let's copy this one. Sudo copy node1.conf. And Well, when we installed WireGuard, it created a configuration directory under Etsy called Etsy WireGuard. And under that, we're going to place Node 1's WireGuard configuration file, but we're going to rename it to CIABmesh.conf. I know it seems odd, but it'll make sense later when if you decide to have multiple VPNs and you want a CIAB Mesh VPN, you have a CIABmesh.conf file. If you wanted University VPN, you might call it university.conf, and then you'd also have a university.conf file there. And each one of those can be different, so it's just easy to remember which conf file belongs to which WireGuard VPN that you're working with. So I'm going to rename the node1.conf to CIABmesh.conf in the Etsy WireGuard directory. Then for node 2, I'm going to SCP node2.conf to bmullen. And by the way, I've edited my local host Etsy host file to contain short names for each of these servers, so I don't have to remember their IP addresses. So do-server :home/bmullen. Oops. Sorry. I just have a do. Let's see. Bing do-server. I can't remember what I call it. more/Etsy/hosts. Oh, I didn't. I'm sorry. I did not put it in my host file, so I'll have to use the IP address. So again, IP address of a DigitalOcean server is this. So I'm going to SCP node2.conf to bmullen at the IP address of the DigitalOcean server and put it in the home/bmullen directory. Now if we look, we got a node.conf file there. And again, with this, we're going to copy sudo copy node2.conf/etc wireguard/CIABmesh.conf. And we'll do the same over here for DigitalOcean server. Remember, I'm calling DigitalOcean node 3, or the node 3 configuration file. So again, node3.conf. And on the Hetzner cloud, I now have a node3.conf. I'm going to sudo copy node3.conf. 3.conf/Etsy/wireguard. I don't know if you can hear, but my 14-year-old Jack Russell's laying next to me snoring like a buzzsaw, so pardon that. Yeah, clear some of this up. So now every node's got its configuration file that we created with VX WireGuard-generator. And let's see. Now, in Appendix 1 of this document, my installation guide, I've got a raw FR.conf file. In Appendix 2, I've got the same FR.conf file template, but it's fully commented. So if you're wondering what the commands are in the raw version, that raw version has no comments in it. You can always look at Appendix 2 and get that. So now I want to, in each server, I want to create in each server, I want to create in etc/FRR, that directory would have been created when you installed FR. I want to create an FR.conf file. Right, I've got to make sure I'm doing that with sudo. You have to use sudo with these commands. I'm just going to delete this because, again, I'm going to use my template. The template's very short. It's surprisingly short for the free-range routing protocol. But we're going to paste that template here, save it, do the same here. Oops, again, don't forget to use sudo. We're going to be able to save it. The reason why I'm deleting those lines that are already in the FR.conf file that FR installs is it only has this first line, basically, and a comment, and I'm duplicating that in this file anyway. So now I've copied my template, my free-range routing configuration template for my CIAB Mesh VPN overlay system to each server. And we'll go back, since we've already got that. By the way, I'll just show you, Appendix 2, as you can see, is a lot longer because I've got all these comments in there, but you can look through that if you're that interested. So we are now, we've done step 10, 11, 12. Now we need to edit the FR.conf file in each node to show that node's, or to do some specific configurations. Oops, where am I? 10. Oh, we're on step 11. Sorry. We've copied all that to each node using the template. And now we're going to edit each node in step 13. We're going to edit the FR.conf file in each node and change IP or add IP addresses where we need them to, again, to get those VTEP addresses. We're going to do this, and I am going to need for node, we'll start with node 2, and we'll get the VTEP address. Oops. And we'll edit the fr.conf file. Again, got to use sudo. And where you see insert node 1's VTEP address, well, let's do node 2 since I guess let's get node 1's VTEP address. So we'll get that. And wherever it says insert node 1's VTEP IP address here, we're going to insert that for node 1. And for the route reflector for node 1, then we need node 2's VTEP address. And node 3's. Now, one thing that can save you some time, it's node 3. In the peering statements, I didn't add node 2, node 3's address, so we'll put those in. Okay, one thing that will save you a bit of time is that BGP from BGP neighbors comment through the route reflectors comment, those statements, you can just cut and paste these and replace those two sections in the fr.conf file on the other nodes. So I'm going to quickly do that. Oops. It would help if I put a period there. Oops. If I actually put the period in the right place. And I'll come down here and just delete these statements because they're going to be the same in each node. So we're just going to take those. Now I've saved those in each node. So every node should have those sections the same. Now, in each node, you can enter replace this, enter some password with some password, whatever you want. That will only be used by you if you're on that node and you're going to use FR's CLI commands to edit, manipulate your network configuration. I don't, but that's not to say you might not want to. If you're familiar with enable passwords on, say, Cisco routers, that's what this one's for. I'm just going to put some password for this example. You may or may not use these. Router BGP AS number, I'm going to use 64,512, which I believe is the first AS number that's considered a publicly usable AS number. If you used anything below that, you would potentially get in trouble with IANA and your ISPs for violating the restricted autonomous system numbers. Your business could request an AS number and get one, but not for your individual use. Now, the router BGP router ID. This just needs to be something unique to identify this FR router. Here I'm going to just use the VTEP address for, I'm in the DigitalOcean node, which is node 2, so I'm just going to use that IP address just because I know that address will be unique. And that's just so routing updates will be identified as coming from something named 172. You could have named it pretty much anything you want, but to me it's easier to know that it's the same as the VTEP address in that I used for node 2. Now here, we'll edit this again. We'll put in, some password, and this is node 3. I didn't change that over here, so we're going to go up and change that to node 2. Again, the enable password, whatever you want. Again, the FR router, BGP, each one of these BGPs are configured with the same autonomous system number. That's a requirement if you want this node's configuration to talk to this node's configuration. Only FR router, BGP router, BGP with the same autonomous systems number will talk to each other, or will speak to each other, so we'll want the same one. Now here, this is node 3, so we're going to use node 3's VTEP. For the router ID. That way we know it'll be unique. Oops. Just saving these. Go in here. This is node 1, so we'll just leave it as node 1. Password, again, we'll just put whatever you want. They don't have to be the same on each node, but I'm just doing that for this example. Again, the same BGP autonomous system number, 64,512, and use this node's VTEP address. Okay, now we're almost done. Now, we had said you need to have LXD installed on your system. So we're just going to do an LXD list. And I'd already created one container on the VM1 server virtual machine here locally. That has this IP address. Oops. And that's given out. The container's IP address is given out by the LXD daemon. By default, the daemon provides DHCP and DNS mask for the containers. You can change the profile used when you create a container to not use LXD's DHCP or to not use DNS mask. You can assign your own range of IP addresses. There's all sorts of things you can do, but you can go to linuxcontainers.org and read the documentation about how to do these types of things. Now, I'm just going to copy this. I'm going to edit my fr.conf file. And down here, the last statement, I'm going to delete that because that was just placeholder and put in the network portion of my LXD network. So all my containers on this VM would have an IP address of 10.108.228 dot something. But I'm adding that to the end of the free range routing configuration file because this subnet will be advertised through the BGP route reflectors to these neighbors. So those neighbors, even though the 10 dot network is not routable over the internet, these neighbors will learn that the 10.108.228 dot whatever container or IP addresses belong on this, well, on the 172.20.10.108 node or neighbor. So this is where the VRFs, the virtual route forwarding, is specified. If you had more subnets here, say you had some other bridges, LXD by default uses a bridge named LXD BR0, but say you had some other bridges of your own use, you could specify other networks down here, and they would also be advertised to the other neighbors through the route reflectors. So now configuration for this node's done. And we're going to have to get the list. Okay, on the DigitalOcean node, you'll note that the 10 dot address is different and the subnet address. But we're going to go down here and you only need the subnet or the network portion of the address. So now on node 1, the subnet 1091.56.0, anything on that subnet will be reachable or will be advertised through the route reflectors to the neighbors we've specified, and those neighbors will then know how to reach this subnet. So we'll save that. Now that configuration for FR is done. And I've created a container, LXD container here on Hetzner's cloud with this IP address. We'll go back to the FR config file. Oops. Now, FR is completed. The configuration is completed on each node. WireGuard's installed on each node. LXC list. Do an LXC list. We want to show those addresses again. LXC list. LXC list is an LXD command, CLI command, which shows you all of the containers you have running, or all the containers that exist on that server. And if they're running, it'll show the IPv4 and IPv6 status. There's other information here, which you can look up at your leisure on linuxcontainers.org. So now, again, we've pretty much finished everything that we need to do. But if you note, if I did a IP address, you'll notice these are the only interfaces defined right now. This is the LXD bridge. If we do IP address here, same thing here. Same thing on this server. Now, that's because we have not yet started WireGuard or BGP or FRR, sorry. By the way, in these commands, FRR, because we changed that daemons file, that FRR should use or should enable BGP. When you start FRR, it will start BGP. I just added the restart command. You don't really need this one, but I put it there, so I like just to be sure that BGP is running. So now let's see. We want to be where we can access our scripts. So now we want to do sudo.wg-meshup.sh sudo wg-meshup.sh. Oops. Did I type it wrong? Oh, I didn't. This is why you should put it in all these scripts in user bin. So you, oh, hold on. Sudo copy node 3.conf/etc/ I didn't copy that earlier. Okay, now, and again, now we want to start FR. And again, you could use systemd or create a bash script or something to do these starts for you. You don't have to do them like this. I just wanted to be explicit as far as manually, if you were doing everything, this is what you'd have to do. And so far, this really hasn't taken much time overall. I mean, I'm doing a recording here and explaining stuff out of the document, but ordinarily it wouldn't take this long. And we want just BGP should already be started, and we could PS-x grep BGP. No, it's not started, so we will start it purposefully. And it's giving those errors because remember the restart first stops the protocols, then restarts them. So it's going to show you that it wasn't started, so it couldn't stop it. But it will start BGP. Okay, now if I do PS, now if we do an IP address, you'll see you have a CIAB Mesh interface with 169.254 address. You have a CIAB Mesh interface with the 172.20, and you'll have the same thing on each node. Well, not the same thing, but you'll have new interfaces on each node. And now, if say, let's see, list. Say I want to ping this LXD container running on the Hetzner server. Again, that is a container, so it's on a private network, normally not reachable from VM1. 26.0.13. Oh, I guess one thing I forgot to do in all this, I installed Wireguard, but I didn't reboot the machines. Probably good practice after you do a lot of configuration like this, always reboot first time. So now we've got to start things again. We'll come back. Sorry about this. It's the hazards of explaining things to people in a document. If you've ever written user documentation, I'm sure you understand this. It's hard to think of everything. So now, since I've rebooted, I start Wireguard again. sudo dot/fr.mesh start sh. And we will, for our good conscience, restart BGP. Oops, got to have that / because I didn't put these in user bin. I've got to specify exact path to them. LXD list. LXD list. Ping 10.126.0.13. So from VM1 pinging the Hetzner LXD container in Hetzner's cloud. As you see now, the ping's working, so we are connected. We do have routes. If from here I wanted to ping Hetzner's cloud from DigitalOcean's LXD, or actually I can enter the LXD container, LXD exec do-cn bash. Now I'm inside of the container running on DigitalOcean's server, and if I ping 10.126.0.13, which is the container address on Hetzner's cloud. Oops, it would help if I freaking type. Oops. So from one unprivileged container on the DigitalOcean cloud, I'm pinging an unprivileged container, LXD container, running on Hetzner's cloud. If I want, I can, so obviously ping is two ways, so if it works one way, it's going to work for another, but we'll just prove that. Now, ping from Hetzner's cloud will ping my local VMs. LXD container named CN1, and the ping is successful. So if you're familiar with containers, this is usually something that's quite hard to accomplish, whether you use Docker or if you use Docker, there are different tools like Calico and God knows what to create network overlays for Docker containers. I utilize LXD containers extensively, and LXD now supports virtual machines without having to use VirtualBox or KVM. So this demonstration has shown how now we have complete VPN mesh connecting these containers on 3 different nodes. So, and the VPN is encrypted, highly encrypted by Wireguard. It also supports layer 2 and layer 3 through VXLAN. The use of the layer 3 prevents what's called BUM traffic, broadcast unknown multicast traffic, from being transmitted over the network. And if we were to look at routes from the this container CN1 to the container DO-CN, you would see, the only thing you would see is the route being to the tunnel endpoint, exiting the tunnel endpoint on the other server, at the IP address you're trying to reach. You wouldn't see all the in-between points that the physical interfaces in between that it would have to go through. The VX WireGuard tool is also quite powerful in another sense, in that if later you decide to add more nodes, you can use the VWGen add command to add another node to the master config file, then just extract that new node configuration as an individual node4.conf file, copy that to node4 into etc WireGuard CIAB.conf, and do all the same steps for that new node. And that new node, when you reboot it, would boot up and be part of this internet overlay system. I hope this makes sense to everybody. As I mentioned, anybody that's written user documentation for something this complex, it's easy to overlook something or to assume that what you typed makes sense to somebody else simply because it makes sense to you. But if you've been doing this for quite a while, a lot of times things that are obvious in your mind are not obvious to someone else. So my email address is in this user guide. If you'd like to contact me with questions, or if you find errors or omissions, or suggest different ways of doing this, please let me know. I just wanted to show you that it all does work. IP route show. And if you were to look at the IP route show command, you would also see the various IP addresses that we've added for our overlay network, or VPN overlay network. Anyway, I want to thank you very much. Again, this is Brian Mullen, bmullen.mail@gmail.com. And let me know if you make use of this and any successes or problems that you have. I'll be posting the code and all the code that I've used, the scripts, and this guide on GitHub, and I'll provide that at a later date. Thank you.